Hi, everybody. Happy Friday. So we are still behind schedule, right? We're still on section 5.2, and today we should finish 5.3. And your quiz is gonna be on Monday, and your homework 8 is on Monday. And you can see our schedule. You're gonna be very busy the remaining 3-4 weeks. So if so you can go to Blackboard to check my grades. Okay, so go to Blackboard and you can check my grades. So if you see you're missing an assignment, like homework or practice exams or exam correction and wrapper, or if you don't get 10 points, that means something is missing. Okay, resubmit, and then I will grade those new word missions, and then I will give you points back. Okay, everybody? So please use this weekend to submit all your old homework, practice exams, exam correction, and wrapper. You want to get as many points as you can, right? So let's try our best. Okay, so continue with 5.2. So last time we talked about the logarithmic function, right? The logarithmic function is the inverse function of the exponential function, right? So that's why we have the logarithmic form and we have the exponential form. So if y equals e to the x, this is the exponential form, right? And then the logarithmic form will be x equals ln of y. So you kind of switch the input, okay? So you put the input to the output, you put the output to the input, right? This is base e. And in general, if you have y equals b to the x, then b is the base. So b is the base, you put the b here, and then x is now the output, y is now the input. So they are inverse functions, right, everybody? Okay. And then last time we talked about, okay, how do we find domain? Okay, remember the three list of functions with the domain? The first one, you have square root of a. You need a to be greater or equal to 0. The second one, you have fractions. You need the denominator not equal to 0. And now the third one, ln of a. You need the a to be greater than 0. Yes. So last time we did problem part A, right? We put the inside greater than 0, and then this is how we solve polynomial inequality. We factor it, make sure move all the terms to one-hand side, factor it, find the critical numbers. Plot those critical numbers on the real number line. And it is greater than open circle. And then we look at the leading coefficient. Because it's negative, we start with the right lower corner, right? When we get to those points, because the multiplicity are both 1, so they both are, therefore we cross it and cross it. Okay? And we're looking for greater than 0, so which is above the line. Okay, so this region. And we don't include the endpoints, therefore it's minus 3 parentheses to 3 parentheses. Do you still remember this problem? Okay, let's keep going. Please review your notes. So I have been recording like all the lectures. So if you forgot something, please review your notes, watch the recordings, and come to ask me. Okay? We are behind schedule, so we need to catch up. All right. So problem B and problem C, I will let you to do at home. Okay? Problem D, this is a little bit interesting. Okay, so we need the things inside the ln to be positive. So therefore we need absolute value of x is greater than 0. Okay? But do you know that, okay, we know that absolute value of x is greater or equal to 0, right? Do you still remember the graph of absolute value of x? What does it look like? Yeah, exactly. So it looks like a V, okay? It is at 0, it's equal to 0 at 0, right? So when we say absolute value of x is greater than 0, it means x cannot be 0. Yes, because as long as x is not 0, then absolute value of x is positive. This is the new one. This is the old one. So this is the same as saying x is not equal to 0. Is that clear, everybody? Yeah, this is interesting because we have this problem before. And we know absolute value of x is greater or equal to 0. And then from the graph, it's positive. Oh, therefore it cannot be 0. So x cannot be 0. So you draw the real number line. X cannot be 0. You put an open circle. And then all the other numbers. So if you use interval notation, that is minus infinity to 0, parentheses, union 0 to positive infinity.
So because it doesn't say the number, won't it always be greater than 0 though?
Absolute value is greater or equal to 0. But when you talk about the domain, when you see ln, is whatever inside the ln must be greater than 0.
Then it won't ever be a negative number.
Yeah, because that is
going to negative infinity.
Because your ln, what your ln looks like that. Your domain is all the positive numbers. Your range is from minus infinity to infinity, but your domain is only from 0 to positive infinity. Yeah, good. All right. Yeah, if you have questions, feel free to ask me. And for those of you coming late, please watch the recording and take notes. If you have questions, ask me. Okay, we're already behind schedule, so the remaining time we need to catch up. Okay, so example 3. Simplify each expression. And then we already know that exponential function and the logarithmic function, they are inverse functions. So therefore, we know that e to the ln of x is going to be x, and ln of e to the x is going to be x, because they are inverse functions. How about with outer base? With outer base, we have b to the log bx is x, and log b of b to the x is also x. Is that okay, everybody? This is because of the inverse function, right? When you apply f and f inverse again, they kind of cancel out. You get x back. Okay, look at part A. Ooh, you see this is here. ln and e cancel. So ln and e cancel. You only get 5. So part A is easy. That is just 5. Part B. What's the difference between part A and part B? This 5 is ln of e and then raise the power of 5. And the left one, this is ln of e to the 5th. This 5th is inside the ln. This 5th is outside of the ln. Okay, that's the main difference. And now, what's ln of e? You can think of e as like e to the 1, right? ln and e cancel, so you're left with 1. Is that okay, everybody? Okay, so yeah, you can imagine this is ln of e to the 1. Is that okay, everybody? E is like e to the 1, right? And now, ln and e cancel. You get what? The 1 left. Yes? So, yeah, 1 to the 5th is just 1. So part A and part B depends on the parentheses. You get different answer. Okay, everybody? How about part C?
Just 3?
Yeah, just 3. Part D?
X.
Yes. Part E? X. E and ln cancel. Right. So E and ln, they are inverse function. So they will cancel each other. So these are the rules. E to the ln of x, E and ln cancel, you get x back. Ln of e to the x, ln and e cancel, you just get x back. So this is the rule. Okay, we get this because the way we define natural log is the inverse function of the exponential function. So these are the rules. And then you apply the rule. Ln and e cancel, you get x. E and ln cancel, you get x. How about here? Yeah, exactly. E and ln cancel, you just get whatever left there. So 2x squared plus 1. So far, so good, everybody? Okay.
We don't factor that in? No, that's different.
Oh, yeah, we cannot factor it because it's a plus. Okay? If it's minus, then you can factor its different squares. Right? Yeah, so a plus b times a minus b. But if it's plus, we cannot factor further. All right, so keep going. Find the inverse of each function. So you call y equals minus ln of negative x plus 1 plus 1. Okay, that's the first step. And then to find the inverse, step 2, we switch x and y. Okay, so switch x and y. Then we have x equals minus ln of minus y plus 1 plus 1. Is that okay, everybody? You switch the x and y. And then we want to solve for y. So solve for y, you want the y to be on one side by itself.
You don't take the negative.
Which one?
So it's y and negative x. It wouldn't be negative x and y.
Oh, here we solve for y, right? So we want to solve for y. The first thing is you want to isolate the log term. So we subtract 1 on both sides.
No. When you switch the x and y.
It's only the x and y. Don't switch other sign. It's simply x and y. When you see x, replace by y. When you see y, replace by x. Yeah, just x and y. No other stuff. Right. Okay. And then yeah, so we add subtract 1 on both sides, right? We have x minus 1 equals minus ln of minus y plus 1. So in this process, thank you, you must be very clear what you are doing. We want to isolate the y, right? So we want the y on one side by itself. So we want to get rid of the 1, so we subtract 1. This is an addition. That's why you subtract 1. And then next, do you see this minus sign? Mm-hmm. This is like multiplication. So to get rid of the minus 1, what do you need to do? Yeah, divide by negative 1 or multiply by negative 1. It will give you the same thing, right? So if we multiply by negative 1, what do we get? Yes, very good. So here we isolate the ln term.
What does ln mean? Like, what is the word for that?
Natural log.
Natural.
Yes. It's the log with base e. Yes.
So you just multiply the negative sign?
Yes, we multiply the minus 1 because we want to isolate the log term. Do you see the log term is here? It's not isolated because we have a minus 1 in front of it. So we want to get rid of that because this is multiplied by minus 1. So you either both sides divided by -1 or multiply by -1. It gives us the same result. So we isolate. Isolate means you only want to see that term on the one hand side. All the other stuff is on the other side. Okay, everybody? So once we isolate the log term, we can get rid of that. How do we get rid of that? We know log, ln, and exponential function, they are inverse function, right? So we apply yi on both sides. So yi to the negative x plus 1, yi to the ln of negative y plus 1. Because e and ln are inverse functions. When you see ln, apply e. When you see e, apply ln. Is that okay, everybody? All right. You see on the left, e to the minus x plus 1. On the right, do you see e and ln cancel? So we get negative y plus 1. Ooh. How do we solve for y? Subtract 1. So e to the minus x plus 1 subtract 1 equals minus y. Questions? Can we subtract this one? Can I subtract this one and get cancel? No, because this is on the exponents, right? Everybody, this is on the exponents, and then this is not on the exponents. We cannot cancel them. Okay, everybody? All right. How do we solve for y?
Divided by -1.
Yeah, divided by -1. Then the y equals what? Yeah, we change sign, right? Good. So this is the f inverse of x. So this is the inverse function. And that is our final answer. Okay, everybody? So here are the steps. Put y equals the right hand side. Switch the x and y, and we solve for y. If you see the ln term, isolate it, and then apply the e. This is very important because if you don't isolate it, if you apply the e here, they cannot cancel out. You see when you apply the e here, this is e to the minus. It's not exactly e to the ln. It has a minus sign in front of it, then they cannot cancel. It must be e to the ln. It's only e and ln. You don't have other stuff there. Then you can cancel. Is that clear, everybody? All right, good. Let's keep going. Okay, next problem. Similarly, step 1, we let y be negative 2 e to the 2x plus 1. Is that okay, everybody? And then, what's next? Yeah, switch the x and y. So x is negative 2 e to the 2y plus 1. Right? Everybody? Okay. How do we solve for y? So here, if you see exponential term, you want to isolate the exponential term. Okay. Isolate means we want to have that term on one side by itself. What do? Yes, divided by -2. Is that okay, everybody? This is multiplication, so we divide. This is not subtraction. We cannot add. So make sure you know what operation we should do. So divided by -2, we get negative x over 2 equals e to the 2y plus 1. Is that okay, everybody? Now, E and ln are inverse function. To get rid of E, see, you want to solve for y, you want to get rid of the E. To get rid of the E, you apply ln on both sides. Is that okay, everybody? So apply ln, you get ln of negative x over 2. And apply ln, we get ln of e to the 2y plus 1. So apply ln on both sides. On the left-hand side is ln of negative x over 2, right? On the right-hand side, what happened? Yeah, 2y plus 1. ln and e cancel, we get 2y plus 1. So far, so good, everybody? How do we solve for y? Yeah, subtract 1 from both sides. So make sure you include the parentheses. The parentheses means this thing is inside the ln. And then you subtract 1. You subtract 1. Subtract 1 is outside of the ln. Is that okay, everybody? So don't forget your parentheses. You get what? 2y. What's y? Divided by 2. Yes. So it's ln of negative x over 2 minus 1, all divided by 2. So this is the f inverse of x. So everybody now clear how to get rid of ln or e? So we just apply the inverse function. But before you apply it, make sure you isolate it. Because like this steps, when you put ln here, ln is not next to the e and you cannot cancel. Okay, everybody? You must isolate it first. Then when you apply ln, you can cancel. Alright? So the isolate part is very, very important. Okay, this is part B. Okay, example 5. Let's make the problem more interesting. So let's put negative 2 ln of negative x plus 1 and then plus 3. Let's do this. Okay, let's make it more interesting. Alright, so this is transformations. Okay, so this is like what we have been doing, but our parent function now add one more, which is, in this case, is ln of x. ln of x is going to be an increasing function, and it passes through 1, 0. So only one key point, the 1, 0. Is that clear, everybody? But you have a vertical asymptote. What color is more obvious? Maybe the green one. Do you see here we have a vertical asymptote, x equal to 0. Okay, so this is the parent function. Okay, this is the parent function. Last class we talked about exponential function, the parent function. Now is the log. Okay, ln of x is an increasing function. Okay, so we do the transformation. What's the order of transformation? The first thing, what do? Left or right? Do we have left or right? Yes. Oh, add 1. Left or right? Left, yeah. So y equals ln of x plus 1. So this is shift left 1 unit. Is that okay, everybody? And now what do? So we have the key points. We shift left 1 unit. Oh, you see now it becomes 0, 0. So we have a point here. We shift left 1 unit, then it's at 0, 0, How about this vertical line? You shift left 1 unit, that is at x equals -1. Yes. So -1, you put a dash line there. And then the shape remain the same, like that. So far, so good, everybody? All right, next one. What's the next? So shift left or right, and then next one. Reflection over the y-axis first. Yeah, y-axis. Okay, so that means what are you looking at? You have a minus sign in front of x, right, everybody? So this is reflect over the y-axis. Okay. So do you see this point? This point just stay here, right, everybody? And then you pick some other point. Let's say this point. Okay, and when you flip it over, it's kind of here. Do you agree? And you pick some point here. When you flip it over, do you see it's here? And how about the line? Yeah, so now it's at what? 1, right? So, and then connect those points together. So this is at 0. So far, so good, everybody? Alright. So this is refraction over the y-axis. What's next? Refract over the x-axis because we have a minus sign in front of the whole thing. Yeah? Alright. So we have y equals negative ln of negative x plus 1. Alright, so this is reflect over the x-axis. Okay. So if you kind of forget some of the transformation, watch the lecture video on session 2.5. Okay? And so keep going. Reflect over the x-axis. X-axis. So what do we do? Okay. Do you see, look at this point, the 0? When you reflect over the x-axis, what happens? It stays there, right? Yeah? How about this point? When you reflect over the x-axis, oh, it's down here. Okay, so that point here, and then this point, go down, is like here. How about this point? It goes up, right? How about this line? When you reflect over the x-axis, what happens? It stays the same. Yes, everybody? It's the same thing. So we use green color at 1. We have a dash line there. Okay, and then we connect those points together. 0. Okay, what's next? Yes. So y equals -2 ln of negative x plus 1. This is vertical stretch by a factor of 2. Okay, and then, so in the exam, you want to be able to show me the difference. So therefore, what happened to this point? Your x-coordinate remains the same, your y-coordinate multiplied by 2, but same, yeah. So it's 0, 0. How about this point? You stretch by a factor of 2, right? So which means it was here, oh, you stretch. This is the new point. Can you see? So this is the new, oops, I don't want to erase that. Okay, that's the new point kind of here. Okay, so kind of here. How about this point? When you stretch, we got this is the 2 times that, right? So it's here. So we get here, kind of like here. How about with this line? When you stretch, what happens? Stay the same. So we have the line 1 and stay the same. And now connect those points together. So this is what it looks like. So in Excel, even though you don't know what exactly this point is, but at least comparing, you can see it stretch. It gets stretched. Okay, everybody? Mm-hmm. Last one, what's that? Yeah, up 3. So shift up 3 units. Okay, shift up 3 units. All right, this point, move up 3 units, then we're at what? The 3, yes, everybody? And that point, shift up 3 unit, it kind of be here. This point, shift up 3 units, kind of be there, because it's not so accurate, so it's okay. Just a rough estimate is fine. How about here? What happens to this line when you shift up? This line you shift up?
Yes.
Then
Just stay the same.
yeah, stay the same. Exactly. So we draw. Okay, 1 is stay the same. Okay, and therefore connect those points together. So this is the picture. Okay, and for this kind of problems, the question also asks you find the domain and find the range. Do we have vertical asymptote? Do we have horizontal asymptote? Okay, look at the domain. Domain is you project your graph of the x-axis. You see the shadow is here up to this point, right? Do we include this point? Do we include this point? No. So it's from minus infinity to 1 parentheses. Okay, minus infinity to 1 parentheses. How about range? If you project on the y-axis, what's your range? Yeah, very good. All real numbers. Minus infinity to positive infinity. Do we have vertical asymptote? Do we have vertical asymptote? Yes. X equals 1. So x equals 1. Do we have horizontal asymptote? No. Okay. Let's finish the problem. So for exponential function and logarithm function, the problem will also ask you domain, range, vertical asymptote, and horizontal asymptote. Oh, you project on the x-axis. Look here, shadow. See, the shadow is here. Minus infinity to 1. I'm not including the 1. Okay. So yeah, that's why you need to draw the key points and the horizontal asymptote or the vertical asymptote. Yes.
How do you know that? Vertical asymptote is important.
That's the parent function. So your exponential function, you know, it passed through the point 0, 1, and it goes like that. Okay, this is the key point 0, 1, and it has a horizontal asymptote y equal to 0. So do you remember you have a bank of library of parent functions? Now you add exponential function and the logarithm function to your list.
So would there be a horizontal axis if it didn't go through the y-axis?
Didn't go through the
Wait, what do we ever need So if it doesn't go through the x-axis, that's your final.
Yeah. Got it. So natural log of x, your shape looks like that. So you have the y-axis is the vertical axis. Exponential function increase like that. The x-axis is the horizontal axis. Yes. So and they are inverse function. You see that they are mirror image about the line y equals x.
So when we're doing exponential function, we find the vertical.
You say no vertical.
No vertical s.
Exactly. Yes.
Okay, very good. So keep going. All right. Okay, now one way to solve the unknown in the exponents is to rewrite the equation in the log form. So we will see that later. And this equivalent way to take the log of both sides. Okay, so let's look at the following problem. Okay, so we want to solve equations involving exponential expression or logarithmic expression, right? And the first thing is you always isolate the exponential term, okay? And second thing, to get rid of the exponential term, you apply ln on both sides. And then you can solve for x. So these are the steps. Okay, first, do we have the exponential term isolated? Yes or no? Yeah, see, it's only almost the left-hand side by itself, right? It's already isolated. So we can apply ln. So ln e to the 2x plus 1 equals ln of 30. Is that okay, everybody? So, and now ln and e cancel. Right, everybody? Then what do we get? Yes. Solve for x. What do we do? How about you guys take turns to answer my questions? Quinton, what do we do now? And e? Oh, because they are inverse function. They are inverse function. That's why we can cancel out. So this is the rule. E and ln, they are inverse function. So when you see ln of e to the something, ln and e cancel out. Or if you see e to the ln of something, I think you mean this rule. Did you copy down this rule on your paper? So e and ln, they are inverse function. Then they cancel out. Okay? ln and e, the inverse function, they cancel out. So this is the property of inverse function. F composite with the inverse function, they cancel out. You just get x back. Is that okay? Oh, here we don't have e. There's nothing you can cancel. So we still have the ln. But on the left-hand side, it's ln of e to the 2x plus 1. ln and e can cancel. But on the right-hand side, you don't have e, so nothing can cancel the ln. You still have ln of 30. So now we solve for x. How do you solve for x? Subtract 1. So we get 2x. How about on the right-hand side? I want to ask you questions. Can I subtract the 30 minus 1 and get 29? No, we cannot. So ln of 30. 30 is inside the ln. Okay, everybody? ln of 30 is not 30, so you cannot subtract 1. Okay, so leave it like that. Don't put this as ln of 29. You won't, okay, everybody? Don't do that. Okay, next, what do we do? Nikema. Divided by 2. Yes. So x is ln of 30 minus 1 divided by 2. Okay, everybody, take out your calculator. Type everything in one line. Okay, I know sometimes maybe you compute one term and then do another one and then you do another one. My suggestion is type everything in one line. So you put parentheses. Do you see that LN button? Put LN button and then type 30 and then put a parentheses there to indicate that you finished of the LN inside part. Okay? So put a parentheses there. Subtract 1. Put another parentheses. This parentheses together with this parentheses indicate this is the numerator. And then divide it by 2. What do you get? Oh, you forget parentheses in front.
No, oh no, let's do that.
Yes. 30. Mm-hmm. 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 Divided by 2. Yes. Do you get that? So, okay, type everything in one line. So, parentheses, ln, you see ln? 30, close parentheses, minus 1, close parentheses, divided by 2. Okay, see, this is what we want to enter.
Yeah.
And enter. So enter everything in one line. Mm-hmm. Do you get 1 point what? Oh, 1.2005. What's the next digit? 9. Oh, okay. If you get 9, then you round up, right, everybody? Mm-hmm. Okay, very good. Type B. Yes. How many digits? Oh, usually on the exam, I would say, please approximate your answer to 3 decimal places. Then you know to keep 3 decimal places. Okay, yeah, good questions. And part B, if you have, this is exponential function, right? So you also isolate the exponential function. In this case, the exponential function is what? 10 to the 2x minus 4. How do we isolate that? We subtract 2 or we add 2? Yes. So add 2. We get 3 times 10 to the 2x minus 4 equals what? Jackson? 12. What do we do next? Yes, do you, Jackson? We want to isolate this term. So what do? By the way, can I multiply the 3 and 10 together to get 30? No, we cannot, because this has the exponent, this has no. So we want to isolate this. So we don't want to have the 3, we don't want to have -2. So what do you do with the 3? How do we carry out that? Yeah, we divided by the 3. 3 and 3 cancel. Do you know what's 12 over 3? 4. Right. Okay, so we get 10 to the 2x minus 4 equals 4. Right, everybody? This is exponential function, but with base 10. Then you apply log base 10 on both sides. Okay, everybody? Log base 10. Apply log base 10 on both sides. Log base 10 of 4. So log and exponential function, they are inverse function. Is that okay, everybody? When you want to carry out the exponential function, you apply the log. They cancel. We get 2x minus 4 is log base 10 of 4. How do you solve for x? Even.
Yes.
What do we do?
Add 4 on both sides.
Add 4 on both sides. Can I add this 4 and this 4 together to get 8?
No.
No. So it's log. By the way, if we put log, that means base is 10. Is that okay, everybody? Mm-hmm. What's next? Peter. Divided by 2, yes. So we get log 4 plus 4 divided by 2. Questions? Can I cancel this 2 and then this 4? Or this 2 and this 4? No, because this 4 is inside the log. Do not cancel. And you cannot just cancel with one term. You have to do both, okay? But this, because we cannot cancel this term, we're not able to cancel it.
Why did you take away the bases then?
Because we want to get rid of that.
Yeah, I mean, the log base thing.
Oh, because if you don't write anything, it means the base is 10. If you have ln, it means the base is e.
So we can keep the 10 if you want.
Yeah, you can keep the 10 if you want. Yes. Sure. Okay, now go to your calculator. Do you see that button, log? Yes. So type everything in one line. Don't do it multiple parts. Just one line. Parentheses. Parentheses. Log. Or you close the parentheses, right? Yes. Plus 6 is plus 4. And then divided by 2. Oh, don't forget the parentheses there. And yes. Oh, so there you don't need parentheses. You need to close parentheses to close that before you go into parentheses. 2.301. Do you get 2.301? Yes. Okay, so we get 2.301. So that's the answer. Okay, so make sure you know how to use your calculator. Okay, by the way, come back to this problem. Do you remember, if we have both sides with a different base, we kind of guess that, right? And that is why we introduced the log function, because we can apply the log base 2 on both sides. You see? To carry out the 2 exponential function, we apply the log base 2. Right? So, do you see log 2 cancel? You get x. Right, everybody? But your calculator only has log button and ln button. It does not have the log base 2 button. Okay, so how do we calculate this? Well, we need section 5.3, which is the change of base formula, in order to do this. Because we don't have enough time, so we continue on Monday. So, okay, it's quite challenging. We had 2 lectures behind. So this weekend, promise me submit all your own work, okay? Homework, practice exam correction and record. Look at me. Okay, so do it. I will check on you. Try your best. You want to do well in our class.